Bhaumik Goyal, and this is my Ell project. I have made a project on the working of a simple AM radio. So this is an AM radio. Uh, so we will study basically each components of the AM radio in detail, the antenna, tuner, detector, speaker, and we will try to answer the following question: how does the radio convert AM waves into sound? How each of the component works, and what is the need of each of the component? And this is the circuital diagram of this same radio. So basically this is the antenna, this is the tuner, this is the detector, and this is the speaker. First we study about electromagnetic waves. Electromagnetic waves are nothing but electric and magnetic field oscillating perpendicular to each other and their direction of propagation. They travel at a speed of light. So this is the electromagnetic spectrum, and we are just concerned with the radio wave part of the spectrum. So the order of wavelength of AM waves is basically of 100 to 1000 meters, as we can see in this diagram. So what's amplitude modulation and why we need it? So the message signals are of very low frequency and they cannot be transferred over long distances, so we need to modulate them. So amplitude modulation is a modulation technique used in electronic communication, most commonly for transmitting messages with a radio wave. What we basically do is we mix our audio signal with a high frequency carrier signal to get a resultant amplitude modulated signal, and these are propagated using towers, and it is the function of the antenna to then convert this AM electromagnetic waves into an electric signal. So what's an antenna? The EM waves causes electron to move back and forth in a conductor with the oscillating electric field, and thus it acts like a source of AC supply. So here there is a simple representation. Due to the electric field, there is a current in this conductor. Due to the changing direction of the electric field, the current through this resistor keeps changing its direction, and thus we can consider it as a source of an AC supply having a frequency same that of in case of this electric field. So then comes the tuner. So what happens is the electromagnetic waves incident on antenna acted as an AC supply, as we studied in the previous slide. So thus we are now inputting a bunch of different frequency of AC signals to this tank circuit. The tank circuit is nothing but the tuner itself. So the resonant frequency of this tank circuit is 1 by 2 pi under root of LC. L is the inductance and C stands for capacitance. So what happens is the frequency of the carrier signal which matches with the resonant frequency of this tuner or the tank circuit is allowed to pass into remaining part of the circuit, whereas the other frequencies are attenuated, and the degree of this attenuation is called selectivity. So as a result, only a single carrier wave is allowed to pass from the tuner. And then comes the detector. So why we need a detector is because the frequency of carrier signal is very high and the speaker cannot respond so quickly. So we need to recover the original audio signal which is encoded in the AM signal. So the detector is a simple AM receiver which consists of a diode and a parallel RC circuit. It helps us to get rid of carrier wave and to obtain original audio signal, as we can see here from in the figure. So how does it function? Basically, the carrier wave that comes through the tuner into the diode The diode allows the current to flow in one direction only, and thus the AM signal changes from this to this. Now this long sequence of voltage spike encounter this RC combination, and note that this RC combination has a very large time constant. So when this voltage spike encounters this RC circuit, it charges the capacitor to its corresponding peak voltage, and since the time constant of this RC combination is very large, the capacitor will not discharge, and till then the next spike will arise, and this pattern we will be able to recover our original audio low frequency audio signal, and this signal is then passed into the speaker. So the so then the audio signal comes into the speaker. So the speaker consists of small coil called the voice coil and a permanent magnet. This is the voice coil, this is the permanent magnet, and basically what happens, due to the audio signal there is a current in this coil, due to which it experiences a force from this permanent magnet and starts moving back and forth. The diaphragm attached to it through leads also moves back and forth, thus producing pressure waves, which we interpret as sounds. So here I have applied the various concepts taught in class, such as the steady state responses of inductors and capacitors, uh, resonant frequencies, tank circuits, and many more. So thank you.